Okay. Okay. So let's pull up. Um, let's say 3, 4, 5. I mean, I think we did less about I don't know, maybe about maybe yeah, 3, 4, 6. Okay. So here's my suggestion. I think the best row is this. Okay. Turn off microphone. Your background noise. All right. Well, that. All right. Kiana, turn off the microphone. Oh, that's interesting. What's that noise?
Your microphone's off again.
Huh?
KM.
Ah, okay, hold on. I'm sorry.
Yeah. Thank you so much. All right. Okay. Thank you so much. So here's one. Let's begin. Yeah. So let's plot this point here. 3, 4, 6. Okay. So plot. So I thought about this. Okay. So plot 3, 4, 6. You know the easy way? Do this way. First of all, let's put the z. Draw this just like xy. Put this as y. Okay. All right. Please follow me. Okay. And I suggest, you know, about 45 degree here. 45 degrees. 45 degrees. Draw this line. Say this is it. How is that? Huh? Pretty cool, huh? Isn't it? Yes. So this way you could create 3D effect. I mean, I know it's kind of little. I think it's kind of too much. I think this might be better. Yeah. So put the plus sign. This time put y and the 45 x. How's that? Good. Yeah. And then so here. So how do you do this? You know, make sure when you mark the what values, make sure it's parallel to the what opposite side. So to create the defect, say this is 1, 2, 3, right? And then 4, make sure it's parallel to x-axis. 1, 2, 3, 4. And then you could connect the hologram. Yes. Cool. Hologram. What do you know about the parallelogram? Opposite sides are parallel. Okay. Who's in and then yeah. Kiana, all right, let's turn off the microphone. And then, so Chambus, you could turn off the what? Your camera if you want it. Yes, you turn on your camera. Yes. But once in a while, I'm gonna ask you to turn on it. Okay. And then what happened? Opposite sides are parallel, isn't it? Right? I mean, congruent, isn't it? They're same. That's a property of parallelogram. So this is a fundamental concept we learn from geometry, right? It's like the parallel, and then opposite sides are congruent, right? Same in length. So yeah, true to parallelogram. Everybody type the points location. 1, 2, 3. Type it. Type this location. Okay, on chat, could you tell me what is this locations? Chatting, please tell me the location of this point. Yeah, 3, 4, 0. Yeah. Okay. So then it's gotta just increase what? Increase what? 6, isn't it? Up. So then how do you do this? I know it's kind of, I know it is like line. We could say, 1, 2, 3, 4, 5, 6. Better way might be this here. Make it to here. Yeah. When you do the g-axis, make sure it's parallel to the x-axis. I mean y-axis. Okay. So this time straight. Excuse me. 5, 6. Yeah. Then what do? Parallelogram. What is a special parallelogram? I think y is a plane. Parallelogram is rectangle, right? Because it's a parallel, right? A rectangle is a special parallelogram, isn't it? So, what is this point? Location. Please tell me the location of this point. All right, people, type it out. What is the location of this point? Yeah, it is what? We're not moving 0, 4, 6, right? So we know we have to come 3, right? So how do you, I know you have to go up 6, you have to come to 3 forward, right? So how do you do that? Make a parallelogram here. Again, here, make a parallelogram on xz plane. Remember, parallelogram or rectangle, these are all rectangle or curve one, right? So we're making box here. Make a box here, right? If you make a box, one of the corner is your coordinate, isn't it? Go ahead, it's in here. Yeah, it's a parallelogram there. This one again, right? And then I think this actually, these are all 6, 6, 6. Right? It is what now? Rising. 1, 2, 3, 4, 5, 6. So 3, 6, 4. Isn't it? All right. So now, let me see your drawing. Why don't you turn on your camera on your screen? Show me your drawing. 3, 4, 6. We want to see. We want to see your drawing. Okay, so why don't you turn on your camera? Show me your drawing. Let me see. I'll tell you. All right. Put your picture on the screen. Let me see. I'll tell you. I'll give you some feedback. All right. Okay, here we go. It's like, you see how calculus goes? We're learning how to plot, right? Oh, wow. Very good. Look at, folks, look at your classmates with pictures. Yeah, hold on to it. We want to see it. Yeah. Okay. Can you make it closer? Yeah, Alejandro, I see very clearly. Arlene, I don't see it. Lower it a little bit here. Yeah, let me see your picture. Yeah, very good. Yeah, okay. All right, Matthew, show me more closely. Yeah, I cannot see. Yeah, very good. Yeah, folks, look at other picture. Yeah, very good. Everybody's. All right, now, Ayan, and then, yeah, Vanessa, your picture is pretty good too. All right, very good. Everybody, all right. Huh? That's good. I see yours. Yeah, Richard, very good. Troy, show me a picture. Let me see yours. Okay, let me see, Troy. Troy, okay. Okay, that's good. Yes, Ramiro. Yeah, Ramiro is pretty good. Christopher, okay, very good. All right, Mungchin, yes, very good. All right, that's good. Okay, so you guys got it. Okay, you could turn it off. All right, very good. So, plotting first. Think about here's one. What do you think we're going to do? Chapter 12 is something, imagine we're taking calculus. We're taking like a plot the point, right? And the graph, right? Then later, integration, whatever, and we take calculus, right? I think we're gonna follow this track. So now we're in almost like a algebra 1 level. Yeah, I think it should be all, Justin, make it parallel, right? I think my drawing is not kind of little crooked, but keep drawing parallelogram. You know how to draw the box, right? This is how you draw the box, right? You know how to draw the box program? And like down, straight down, right? Make the rectangle and make it, right? This kind of thing. And then behind, you draw the dot point line, right? So what do you know about the box? Their opposite sides are all congruent, right? These are all congruent. That's the factor we're using, isn't it? Right? I mean, they're all same, right? So you got this point, whatever. Okay, let's go. So look at this one too. I mean, sometimes I thought, should I negative number 2? Okay. Can you guys plot this one? All right. Plot -4, 3, -5. Okay. Why don't you try? Okay. Plot this one. Take a time. Plot this one and show me your picture. I'll do the same thing too. Okay. You guys go ahead first. Yeah. Plot this one. Positive coordinates, but negative sometimes confusing. Okay. But I think it. All right. Try this one. So I suggest draw. It's a down, so I guess draw Y. See, make it perpendicular, and then 45-degree cut. 45-degree cut. Oops. Yeah, start plot. See what we can do. Yeah. Oops. I need more space. Negative parallel. Look at this tally here. Make sure it's a parallel. Don't draw the line like this. Okay, this is what mistake. Then you get kind of things messed up. Okay? Yeah, just draw something like this. Make sure this is parallel to the y-axis. 1, 2, 3, 4. Indicate -4. And then 3. 1, 2, 3. So make sure you draw the parallel. Yeah. Mark the point here. What is this guy? -4, 3, 0. Then what happened? It goes down -5. Just go down. It's going down 5 here, right? Like 1, 2, 3, 4, 5. Something like this, right? Yeah, this is -5, isn't it? So how do I do this? I mean, you could draw this one nicely later, right? If you want it, right? Something like this. Then you get, this point, right? From here, you go down 5, isn't it? Yeah, that's the easy way out. If you understand this, type yes, please. Type yes, if you understand it. Yeah, I mean, this kind of cheating way, but if you want more official one, then I think we could do, I could do, I lost my y-axis. Yeah, then you mark 5 down. 1, 2, 3. This one make it straight. So then start to going down here. Yeah. And then what is this point? This point is what? 0, 3, 0, right? Going down 5. This guy's what? 0, 3, negative 5, isn't it? Then, you know, right? You have to go backward by negative 4. Yeah. If this is negative 5, then this should be negative 5 too, right? To create a 3D effect, isn't it? So negative 4, 3, negative 5. Here we go. Okay. Any questions? All right. So practice. All right. Let's go. So now let's get to some math now. Here, mathematics. So here. So what is up this? Okay, I think first thing we'll this. What we're doing. So distance formula, you know, all kinds of things. All right. So let's say here, distance between these 2 points, here and here. So this is x of 1, x, y, x of 1, y sub 1, z sub 1. This is what? Yeah, what is this distance here? Distance here. Distance, right? E. It's obviously this distance is, what is that? Okay. So here, that distance is ground is what? This distance is. Okay. So this is what distance between, you know, let's do this one first here. Let's start easy way. I want to make it easy. So say this is maybe A and maybe A and C, you know. So obviously, what is that? C square equal A square plus C square, right? Isn't it? So what is the A? What is the C? And then I think that we're gonna say E is what later? A square plus C square, isn't it? Sure. So what is A then? A is interesting. Look at this ground triangle here. Ground triangle. I think this is here. This and this. If you look at this ground triangle, this is basically x of 2 minus x of 1. And this is what? Y minus y. Right? So a square equal x of 2 minus x of 1 square plus y sub 2 minus y sub 1 square. Right? It's absolute value. Put the absolute values. And then so a equal, yeah, that's this. So that's A. What's C? Yeah, C equal G sub 2 minus G sub 1, right? Yeah, that's this guy, right? Use absolute value. Distance between 2 points. Yeah. So here, obviously, I mean, basically, what is it? A distance. So you what D is. All right, everybody's. What is a D? What is A square? Can you write down? right. I guess square case, we don't need an absolute value, isn't it? If you have the same answer, type yes, please. 1, 2, 3, type yes. Everybody type yes. So as you expected, it looks like a distance formula, and it is really, isn't it? Does it make sense? Any questions? Think of this way here. Isn't that what A is this, right? Distance formula between 2 points? And it's obviously what? D is what? I mean, T square equal this square plus that square. That's, isn't it? Make sense? Okay. Any questions? Easy? So practice this one several times. Don't memorize. I mean, you could remember, but I wish you could remember this by doing this. There's a what? Space triangle. There's a ground triangle. Let's call it ground triangle. Ground triangle is actually the what? Our algebra 1 triangle. It is. Because it's on the plane, z coordinate doesn't count. So we know this is length is a distance between 2 points. But height is this. So now we're using Pythagorean theorem. Yeah, this guy square plus this guy square equal this guy square, right? And you put the square root. Make sense? Okay. All right. So now here. With the center HKL, radius R. Okay, everybody type the. You had an equation for the circle, not sphere. Write down the equation, please. Okay. So I think we could use a distance formula here too, right? Yes. It is. What is this? The distance formula. What is that? Distance between this point, any point on the circle, sphere. What's that? X of x minus h square, y minus k square, z minus l square. You call that distance? You call it r, isn't it? Right? Yeah, very good, Baron. Yeah, of course you're right. So we know the analogy why it's same, almost same as circle, isn't it? Yeah. And then what happened? There's so many points on the sphere, so many x, y, z. Yeah, so many x, y, z here. But what do you know? Their distance, center to that point is always r. collect all the points satisfying this equation. They make circle, sphere. So you square both sides. Yeah, just so instead of just memorizing, you think about it, right? You think about why this is true. Yeah. So then what is a sphere? A sphere is basically collection of all the point x, y, z satisfying this condition. You collect all the points satisfying this condition, that makes a sphere. This is a sphere equation membership requirement. You collect all the points. How many points are there satisfying this condition? There are infinitely many of them. You collect all these billions of points satisfying this condition, and then that collection of the point is called sphere. Does it make sense? It is a sphere equations, but you collect all the x, y, z satisfying this condition. There are infinitely many of them. We put them all together, and they become a group that set is called sphere. If you understand my argument, type yes, please. Yeah. I mean, it's something obvious, but let's think about it, all this little thing. Okay. So, any questions? All right, no questions, we move on. Okay, now here's one. There's so many points making this shape, right? It's like, what does it look like? Please tell me, what's the name of this? Okay, everybody, type the name. What does this shape remind you? All right, name something. This shape, shells. All right, semi-sphere. Okay. I don't know. Yeah, it looks like a half of the like a chocolate ball. Suppose the creamy portion, so it's core is empty. Or egg. How about egg? I don't know. Half sphere, but I think what we want to do is let's say pen. Let's get a better color. Yeah. Bad thing here. Yeah. Let's describe points satisfying this condition. What are those? This shape. All the point x, y, z satisfying what condition? All right. Write down the condition. Please write down this. You write down something. Okay. You want to? I know there's so many points. I know there's so many points x, y, z. In space, so many points. But which point x, y, z do you have to collect so that you make this shape? All right. What is the equation for this big sphere here? Can you write down the equation for the big sphere? Yeah, all of them. Let's say all of them made. Suppose that we try to make this, and suppose that you are kind of you're the subcontractor of SpaceX, okay? And SpaceX is asking you to make this part. And usually now, what we do in machinery is we program it into the machine, and the machine gonna carve this out. So what is the condition you're gonna put into your machine so that you have this shape comes out? Okay. First of all, tell me the equation of this big sphere. What is the big sphere equation? It is what? What is the center? Center is with the center, the origin. And what about radius? What is the radius? Particle? Okay, write down the equation. What is the equation of this sphere? Outside, big sphere. Yeah. Can you tell me? Okay, please write down the equation of this big sphere. What is that? It's x minus 0 square, right? Y minus 0 square Yep, z minus 0 square equal 2 square. So you're right, Chebujin, right? Chebujin, it is simply what? X squared plus y squared plus z squared equal what? 4, right? Kind of thing, right? Yes, that's big sphere. Okay, everybody agree? Okay, Chebujin, write down 2 square, not the 2 square. Yeah, so check this out here, Chebujin, here. When you know why it's a radius square? Check this out here. This is the reason we square both sides. You know, that's why you eliminate the radical, but also you have to square this, right? Isn't it? Yeah, isn't it? Yeah. So it should be 4. So Arlene's answer is correct. 4, right? Okay. Because, you know, just let's remember this, you know, why did you square? Because I want to knock down this radical, you know. Hey, make people square your radius too. Make sense? Okay. Oops. Okay, so now let's write a look at this small sphere. Small sphere. Okay, folks, write down the equation for small sphere. 1, 2, 3. Type it up. Write the equations of small sphere. I think they say yeah, it's 1 and a 2, right? All right, 1, 2, 3. Type the equation. Okay. On chatting room, give me the equation. All right, you're good students. Everybody knows this. Yeah, center is 0, 0, 1, 1 square, 1. All right. Okay. Yeah. So what do you realize? All the point here. Okay. Anyone has an idea here? Write down something here. What is that here? To express all the shape here. You know, what our responsibility is. I mean, this part. Our portion is up to here, but whatever, it's all coming out from there, right? Yeah, it's all this. All right, anyone? Write down this way. All right, everybody's. Feel now. You know what to do, right? All right, 1, 2, 3. What's the first number? Yep. Cameron. Yes, very good. Very good. You know, look at the Cameron's answer. Cameron, you're right. Okay. Draw this. If you collect only this, oops. What if you have only this here? Yes. So let's say this. Okay, draw the shape of this. Let me see whether you draw this one correctly. Just look at not your question, but if you look at this, what happened here? It is basically this whole chocolate, right? Maybe creamy inside, right? Something like egg, like missing the what? Yolk, right? Yeah. So that's not quite this. Yours is only half of it, right? That's not. It is what it is like a sort of avocado, you know, without the seed. I don't know, something like that, right? So it looks like a half of the avocado. I don't know, assuming the sphere avocado, right? And then the Cameron did a very good job. But what happened here? You need one more condition. Z is less than or equal to 1. Everybody, 1, 2, 3. Type answers. Type the answer for the last box. Everybody type it up. You're right, and you'll never ever forget this argument. Good job. So why this is important? When you design part for the Falcon 9 of SpaceX, we know it involved hundreds of thousands of parts, isn't it? You know how SpaceX manufactured this? They don't manufacture any of this. They simply pre-order from thousands of subcontractors, and they specify the design. And I think whoever subcontractor, maybe they get the order from SpaceX. Maybe SpaceX says some company subcontractor is asking subcontractor. SpaceX will specify, okay, why don't you design this one? And then subcontractor will put this one to machine. Now the machines are all kind of computerized. The pre-run, the machine will carve out this shape. Make sense? That's how things works. Yeah, nowadays, in the long ago, you know the what? This mechanic, they kind of carve out the stuff, right? But nowadays we use a machine, automatic machine will one specification like this, it'll carve out this shape. Make sense? All right. If you understand this argument, type yes, please. Let's see how many people understand it. Yeah, fun? Yeah, okay, good. So just think, you know. All right. So I think your book has a what answer something like the only right. But I think it's better to say send notation here. You know, collection of all the satisfying. This means what? Satisfying. Satisfying. Or such that the following condition. Once you collect all the x, y, z satisfying this condition, then they will make this shape. Okay, good. Any questions? All right, so here's some notation. So this is what you're going to learn in what math, basically 220 to 220. Next semester, you're going to talk about this more in higher dimensions. So when you say R1, it really means it's a line. So it's a line, right? How about R2? R2 means it's a real number, right? It's a pair of, we call vectors. We call this a 1D, right? We call this a 2D, right? 2D is what? Plane, isn't it? Yeah, it's a plane, 2D. We say R2 here. So whenever you see this, how about R3 then? 3-dimensional space. Yeah, that's a little this course. So 3 real number. If you have C3, I mean 3 pairs of what? What do you think the C3 is then? It's a triplet of all complex numbers. That's called C3. Make sense? Yes, that's what you're gonna learn in Math 220 to 70. But we're gonna only focus on the real number in your Math 220. That's called space here. So what happened? You know, X and I'm sorry, Y and Z. My suggestion, put Y and Z. The 65-degree cut, 45. You know, it looks like a 3D, right? Yeah, that's called 3-dimensional space. 3-dimensional vector space. That's called yeah, that's how you do it. Then what does the R4 mean? R4 is space, location, and time. This is one example. X, Y, Z are real numbers. So maybe T is what? 0. Maybe 0 means now. Maybe T positive means future. Maybe T is less than mean past. How is that, huh? Yeah. Past, now, future. How's that, huh? That's called dimensional vector space, space-time. Look at the nice guy. Look at the nice guy. What is the example of this one? R4. Look at the nice guy. Twinkle, twinkle, little star. Okay? Beautiful, nice guy. Twinkle, twinkle, you know, nice. Twinkle, twinkle, little star. I wonder. You know the song? We are here. You are here. So you are the one on the origin, okay? Usually we call this frame of reference, okay? You watch it. Oh, how beautiful the star. I know I could assign location for this guy, right? All locations. Location for this guy, right? You know, you could assign, oh, where is this beautiful twinkle, twinkle, little star? But you know what? You have to assign another thing for each star. Twinkle, twinkle, little star. You say, wow, I love this beautiful star. This may not exist. It may be gone. You're just looking at the past of the sky image. Look at the outside. When you see the sunlight, do you really see the present sun? Light takes about 8.5 minutes to get here. You're always looking at the past of the sun. Any object we see in this night, these are all past. Some of them born 10 billion years, 3 billion years ago. Some of them born about, 7 billion years ago. Our sun was born 4.6 billion years ago. What do you think we have to do? We have to give the location 3, 4, 7, something like this, but also we have to do a sign. Oh, this guy was born negative 6 billion years ago. Oh, this 1, 2, 3 beautiful star, but you're born negative 5 billion years ago. Your night sky is a what? Illusions. It's not presence. You're looking at the movie in the past. If you understand what I'm talking about, type yes, please. Some of them light is what? Traveling what? Speed of light. When the light carry the image to you, your eye, you're looking at the past image. While light is traveling to you, maybe it takes maybe 7 billion years ago, light years away, and this is gone. Maybe it's gone. You're looking at the past. It's a ghost. It's a ghost. It's a ghostly sky. Nothing you see in the sky is a present. You think it's like you're playing old movie at the same time. Does it make sense? You take about 10 screen, watch about 10 old movies. Your perspective, it sounds like a real present, but it's all past stuff. So I'm talking about when you talk about space-time, why we developed this space? Theory of relativity by Albert Einstein. We made up this frame. Okay, make sense? Yeah. To study relativities, we make this frame, 4-dimensional vector space frame. So nowadays, nth order. Someone, can you turn off the microphone? I don't know who would turn it on. Yeah, who turned the microphone? Yeah. I mean, if you have a question, you could ask me. So now, in general, I mean, how are we going to even visualize the nth dimension? What if n is a 10 billion? Where all the x are real number from 1 to k. K is 1 through n. It's dimensional vector space. So you're going to talk about this vector space more in depth, Math 270. So string theory. What is the current problem in physics? The problem we have in physics is now, let's say, we have relativity done by Albert Einstein. It's a grand scale, isn't it? Right? It's a grand scale, right? Grand scale. We talk about this, and then we have quantum mechanics, right? Quantum mechanics. Mechanic. What is spelling mechanic? What is spelling mechanic? How come I forget to? Oh, okay, ME. That's what I was. Quantum mechanic, right? Quantum mechanic. Right. Thank you so much. Quantum mechanic. That's what micro scale, right? Relativity works in the grand scale. It's a whole universe scale. Quantum mechanics in the subatomic level, that works out too. But when you put them together, they don't work out. They contradict. So we try to come up with what? Grand unified theory, right? Grand unified theory. In history, we try to merge them together. That's what Stephen Hawking, everybody tried to put them together, right? One of the we really work out. Locally works, but once we put them together, it doesn't work. I don't agree. So in physics, we're going to come with a grand unified theory, right? That's what we try to come up. One way to explain this is what? Try to put this together called string theory, right? String theory So it's just about theory for everything, right? String theories will come up to explain why they agree. That's just string theory. String theory, I think they look at the universe as well. 11 dimensional world, 11 dimensional. String, yes, not spring. String. Yeah, maybe it could be string theory. Who knows? Sadie, what do you think? It might be spring theory. Who knows? String. Yeah, string theory. So that's an 11-dimensional. We think it's an 11-dimensional universe, 11-dimensional world. So how could he possibly imagine 11-dimensional? So dimension is basically independent factor. It's a building block. Think of it's like building block of the universe. It's 11 different guys, something like that. Yeah, spring theory. Yeah, I like the spring theory. So our concern in our course is about mainly these two guys. Okay? So here we're gonna play real world. Hopefully in the future you can get into a more advanced world. Okay, makes sense. Any questions? It's fun? Yeah? Okay. So let's go. All right, so now let's do graphing now. We learn how to plot. I think I put the GUT as a grand unified theory. I think because you want to put them together, right? Unified. Right. Yeah. So that's what something going on in physics, a big issue. How we bring a gap between relativity and the quantum mechanics. Relativity is about talking about big universe scale, but quantum mechanics talk about subatomic level. Like photon, protons, right? Quark, all those things. All right, everybody, let's go. So let's okay. R1 is a line, All right, let's plot this. 0, 0, 2. Yeah, I'm done. X equal 2, in R2. Write down this way, right? Plane, how do you X, all right, everybody, draw something on your paper. Sketch X equal 2. This just always struggle, right? Always struggle. Let's sketch this. All right. Now make the table. X equal to what is when y equals to x equals 2. Oh. When y equals 1, what's x? 2. Okay. When y equals teaching algebra 1. When y equals 2, what's x equal to? Oh, 2. Oh, when y equals 10 billion, what's x? When y equal -1, what's x? 2. You could change y values, but I'll never change x value. I'll never let's make it myself. I'll never change my x values. If you understand this type, yes, please. Yeah, when you teach what algebra wants to teach them this way, why it has to be up and down. It says you could change all the y values. What does this model? Maybe a space launching rocket, rocket, when you launch it, rocket is keep going up, but 0, means your location. Frame of reference, that's the origin, okay? This is where you're looking at. You know that x will be obviously maybe 2 miles away from the launching pad. I mean, rocket is going, from my point of view, this guy x will never change, but height is changing. Okay. So now, your turn. Your turn. In R3, sketch this guy. I'll wait. You sketch. I give it less from this. I think you should catch it. All right, do it. I'll wait. Sketch this in space. You ready? It says, okay, this example is important. I think that you will understand the concept. Let's make this children's story again. You could change X, Y, and Z all the time. On occasion, my X is always 2. I'll never. You could go. What is a Y mean? You could go, left and right. You could go up and down. You could go right, left and right. You go up and down. Let's say this is the front and back. Okay, X is a front. X is a front and back. Y is the left and right. Z is what? Up and down. You could go left and right. You could go up and down. But I'll never change my X values. You draw the shape. What do you call this shape? 1, 2, 3. Type the name. Everybody type the name. Come on. Good job. You're my good students. Good. You're my good students. It's all about understanding. If you start to understand 220, it's pretty easy. And don't memorize too many stuff, okay? You don't study like that. All right. It says, you could change whatever up and down, left and right, but I'll never change my X value. I never change my X value. It is what? It is a plane parallel to YZ plane. This guy's parallel to what? This guy, right? Plane, right? Y is a plane. Yeah, it is a 2. It's right. You could change the Y and Z wherever. I'll never change my X values. All right. Okay. So now, give me everybody get ready. Y is a plane. Give me the equation. 1, 2. Equation of the X, Y is a plane. Type it up. Everybody type it up. What is the equation of the Y is a plane? Come on, type it up. Give me the equation of Y is a plane. Everybody, type it up on chat. Give me the equation of this guy. What is the equation of this Y is a plane? Very good. Baron, just type Y, X equals 0, X equals 0, X equals 0. Type X equals 0. Come on, everybody, type X equals 0. You could change Y and Z. I'll never change my X value equals 0. That's called YZ plane. Good job. I'm pretty sure everybody understands. Yes? Okay. All right. Okay, I get it. All right, let's move on. Go. In R1, sketch this guy. All right, begin. Fun? I know it's fun. I know you're gonna like my class. Because you will understand everything I lecture next 16 weeks. Don't miss the lecture. Yeah, just use your intuition. And it's fun. Okay? Yeah, very good. Okay. Yeah, let's do algebra. Okay, X. In R1 on the line 0, sometimes it's so challenging this one, teaching to my algebra students. So I teach them this way. It's open. It's not part of it. I just teach them. And then think about it to left and right. It says all the x values are larger than 2. Does 1 work? No. 3 work? Yeah. You know, this is how I teach my algorithms. Make sense? Okay. In R2, I'm pretty sure I know you're good at this. Okay, in the plan, you sketch this. On the XY plane. So R2, 1, 2. Oh, oop, oop, oop. Oh, it's not part of it, right? And all the x values. What are all the coordinates x, y such that the y coordinate x coordinate is larger than 2? It's right there, right? Right there, right there, right there. All right. If you have the same answer, type yes, please. Everybody type yes. Okay, so I know you're pretty good at this kind of thing, you know. All right. Do R3. Using R3. All right. So sketch it. R3. Oops. Yeah, make it 45 degree. I think this is a kind of great way to create 3D effect, right? Isn't it? Yeah, something like this. I mean, it's the whole thing, but I guess it's a good way to. It's like a front of this page, right? Okay. If you got the same graph, type yes, please. Oops. Yeah, you got it? Yeah, it is a front. It is like the wall there, right? X equal to, it's a front. It's not back, isn't it? But not including the boundary. Okay. What do you think? So far, so good? Before I move on, I want to highlight this one. So far, what was your world? Let's look at this one. Did you know that you only play the game on the ground? The ground? Play. Did you know this? You play only the game on the ground. You only play the game this on the ground. Now you're playing the game in space. Does it make sense? This is what happened on the ground, isn't it? Right? Yeah, this is what happened on the ground. If you understand my argument, type yes, please. So what is the R2? R2 means simply doing something on the ground. Now we want to include the game not only on the ground but also in space. Make sense? Yeah. So you've been only playing the game on the ground, basically. XY plane. You called it. What do you call this one? Don't you call this XY plane? Yeah, XY plane. XY plane. All right. So this one, I'm pretty sure you do the same thing. All right. Now let's go for this. So let me say, let's be artistic, okay? All right. So again, this one, take a time here, okay? This guy. Why don't you maybe, I don't know, we could do this one during the alt or whatever. Okay? Yeah, you try this. Now you get the idea. Okay. If you understand what to do, type yes, please. If you understand what to do, type yes, please. Everybody type yes. Yeah, so We could do this one during the office hour or, same too for this, right? Yeah, so, yeah, all right. Let's sketch. Okay, let's try this. Let's try both. Let's try this guy. No, let's try this. Take a time, Just regardless of your XY values, I'm not going to change my Z values. Yeah, how about something like this? Yeah. So it's like basically what? I guess it's first floor, second floor, third floor. I think it's the fourth floor. Isn't it fourth floor? Yeah, how about that? Something like that. All right. If you understand this, type yes, please. Is it? Yeah. Yeah, I mean, that makes sense. Okay. Describe it. All right. In your own words, describe this in building's perspective. Tell me, what does that mean here? Yeah, in your own words. How about this? How do you say this one? How do you describe this? You're an engineer, you're checking the what? Building conditions. Your target of what does that mean? Yep. Yep, very good. Yes. Imagine you're a civil engineer. It's a ground zero to up to floor 4, maybe, right? So I guess, how do you sketch this? I guess I'm going to put something like, right? I think I'm going to put something like this, so that it's not including this, right? So I think we're investigating all the way up to, okay, so something like this, right? Okay. So ground, what? Don't invest. Ground is we're not checking ground, right? But top is what we're checking, right? Yeah. So the whole thing of this is where we're checking the building. That's this guy, right? Yeah, but ground is not included. So I don't know. You can put something like dot 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 whatever. But fourth floor is included. So something like this. Yeah. If you understand this, type yes, please. Easy? Yeah, it makes sense. There's nothing to memorize. Yeah, I get it. All right, let's do more fun stuff. Okay, now you do this. First R2 on the plane. And after that, you drew R3. Let me see what I can do. I'll wait. Okay, so this one, yeah, approximately something like this. How about this? Let me see whether you got it. I'm just curious. Did you get the picture? On the ground zero. So think about it. Y is on this, X is this. So it is like parabola at the back. Something like this. Let's go to a first floor. First, let's go to Z equal 1. You know what you draw here? On the first floor, it says, I don't care where your Z is. I don't care. My X is related this way. my first floor, I'm going to draw this, I'm going to draw this. Oh yeah? Then let's go to the second floor, Let's go to the first floor. Just let me second floor. Okay, second floor. Okay, give me the second is equal to what is XY relationship? This is like ground zero. The second floor XY Z are related by still on the second floor. It is a banded paper. If you understand this, type yes, please. 1, 2, 3, type. It's a parabola kind of shape. Right? It's like you get a paper, you bend it. What is this guy here? Here, do you see me? Isn't this? Isn't it this? It's like bending like this. Yes. Yeah, it's a paper, paper, and then you bend it like this. Yeah. Yes. Okay. If you understand my shape, type yes, please. Yeah, isn't like paper bending it like this? Regardless of the ground, it's always parabola, Wow. How do you like my lecture? If you enjoy my lecture, type yes, please. Do you enjoy my lectures? Yes? Fun? I know you like it. Yeah, so we'll go on this way. So, it's quite amazing. Yeah, twinkle, twinkle. Yeah, Richard. Yeah, I like that. I like the words. Well, it's amazing that from this basic stuff to we hit the what? Amazing, like Stokes theorem, right? And like Gauss's theorem, that's a main idea for physics 1C, Quite amazing, isn't it? Yeah. So let's go together. 16 weeks. I think you will enjoy every single uh, lecture. Okay? I'm pretty sure you'll enjoy it. I think you will. I'll make sure you learn something. All right. So let me ask you. Besides teaching, what do I do? What do I involve? All right, everybody. If you do some research about me, you should know what I'm doing. Sing? Yeah, I do sing. And what do I do in NASA? In NASA, what do I do? What is my interest? I mean, if you done enough research, you should know what I'm doing. What is my interest? Yeah, that's right. So I get involved, deeply involved in Mars human missions. So I hope some of you become my colleague in the future. Yes. Why do you teach? Well, this is a great place to teach. Why? Because you guys are amazing. And I know you're going to be our future leader. That's why I'm here. Okay. All right, guys. So let's continue. Why don't you open up 16 point, what's that? 4.1. Keep working on it. Okay. Working on it. I don't think, I couldn't finish it. So, we'll continue tomorrow. Okay. All right. I got to go. I have a class. Tuesday and Thursday, I have a class at 9:45. Another statistics class. So I have to really finish on time. Okay. Okay. So I'll see you guys tomorrow. Bye-bye.
Thank you, Professor. See you tomorrow.